nothing. This is just 56 divided by 4. That's 14 feet. So if this needs to put out 20 hertz, this line needs to be 14 feet long. 14 feet is 4 meters. That's why transmission lines get really, really big very quickly. Right? Now with transmission lines, like I said, combination of both, we always consider room gain. So the ideal thing should be more like this. This is the 6 dB that's added by the room, and in the room the speaker will perform more like that. Now I'll quickly go to WinISD and show you the difference between this is what a typical closed box output is like. This 0 dB means if it's 1 watt and the speaker says 88 dB, at 500 hertz, which a sub really shouldn't do, so let's just talk about 100 hertz, you're getting the full 88 dB. That is, it is doing what it's supposed to do. But quickly at 50 hertz, if you notice, it's already down, and it's down by 2 dB. Yeah. So if you notice, at 50 hertz, it's already down 2 dB. At 30 hertz, it's down considerably. It's down close to 5 dB. This is what a closed box will do. The response starts dipping very quickly. It's a small box. It's just that. Now, what I'll do is, the same speaker driver, I'll show you what will happen if you switch from this to this. So now what's happened is the response has gone all the way up to 30 hertz, and this is considerable. This is where you start really feeling the bass. But also if you notice, this curve is a lot more gradual. This is pretty sharp, so this is what's called a very sharp dip. So people try and aim for something in between these two. And in your design, this is what you should always do. If you see the box size here, it says 50 liters. Right? In a ported box, it's quickly a lot more. But that's what you have to pay for the performance. And then WinISD, you can also, we don't have these measurements of ports in India. We usually use PVC tubes. I use 2 inches, 3 inches. So 3 inches is 7.62. If you add that here, it will tell you what the length needs to be. And also what you can do is, I'm going to show you something. So we decided to do a ported box, 100 liters. 100 liters is quite large. It's huge. Just watch what happens if I decide to make mine 70 liters. You see that this line has moved up just a little bit from the red part. I'm going to make that even smaller. So what happens when you reduce your thing, right? You remember TJ was talking about Q? This is what Q is all about. So your quality is not perfect any longer. It's more. Means this, your bass is going to sound really, really good. What the purists will say is, no, that bass sounds shit because it's not flat. This is what it's all about. So you can reduce your box size and get your sound up. What you lose is in performance. So if you design your box to be ideal, then your graph turns up and looks good, but your compromise is on the sound. questions, I can take some.
What if you change the number of letters in the closed box? You put it as 50, but I guess that was an input.
Yeah, so this is, I think what WinISD does is it calculates at 0.707 Q value. You can change it. I mean, you can change it. Let's say I put in 100. Doesn't really matter because your performance will just get worse. So I guess what they've calculated is that at 50, the graph is whatever is supposed to be ideal.
So audibly, once, I mean, we know the frequency response is different, but when you actually listen to it, it won't. I heard that sealed is more better.
Sealed is very nice. You heard of this term they say tight?
Right.
Yeah. Tight base? Sealed. And the volume of air in the box is very effective at breaking the cone movement. It's very good because that air is fixed and it literally has a grip on the cone. So the cone and the air work very well together. But it must be an ideally sealed box. If you increase the the size of the box in a seal, then that braking motion actually starts getting effective. So I think what WinISD has calculated is for this driver, this parameters, that is the ideal closed box size, and imported, that would be the ideal thing. Now just one more thing I want to talk about is sound pressure level. Sound pressure level is the norm in the industry is you input 1 watt, right, which is 2.83 volts, and the speaker is supposed to put out 87 dB, 88 or whatever. So in this case, in this example, 1 watt of input is giving you 87 decibels. I'm not sure how many of you have heard of this new phenomenon everybody's talking about called tapped horns. It's a takeoff on the horn principle where, you know how you want to call somebody, you cup your hands. So what happens is you couple the molecules of air and it becomes a very natural amplifier. So tapped horn works on exactly the same principle. The thing with tapped horn is the enclosure size is even more. So 50 liters, 100 liters, 150 liters, but a tapped horn can go up to 400 liters. But the advantages you have with a tapped horn is you don't need a driver that size. You can use a 6-inch driver and you can get a damn good performance with just that 6-inch driver, right? Just one more thing I want to say is this same driver, that is the Eminence, which we use for this example, I'll show you what it's capable of in a tapped horn and what the numbers mean. Now, WinISD says you get about 87 decibels, right? This is a tapped horn design, the same driver again. That's 100 decibels. Now what this means is, from 87 to 100, we've got 13 dB more. Put that in perspective, right? If I'm playing this at 10 watts, I need just 2 watts with the other design. So, in terms of power, that is incredibly efficient. Tapped horn is all about efficiency. I mean, we use a small driver. I know the enclosure is large, but the design is such that you use the smallest of power. You don't need big amps. You don't need lots of wattage. You heard of gain clones? The Rage currently. You can use a gain clone and have incredible subwoofer performance. That is not a tapped horn.